Let's just jump right in. Welcome to This Explainer. We hear the phrase climate change literally all the time, right? But to really grasp what's happening to our world today, we need to completely strip away all that noise and just look at the raw physical science of our atmosphere. So today, we're unpacking the incredibly delicate energy balance that makes life on Earth even possible and, well, exactly how that balance is being disrupted.
Let's kick things off with a massive question, and it's one that honestly causes a lot of confusion. If the climate shifts naturally, which it absolutely does, why the huge global alarm right now? It's a completely fair question. Earth's climate has been warming and cooling since way before humans ever built a single city. So why are scientists sounding the alarm today?
Well, it's absolutely true that our climate has historically been shaped by some really powerful, entirely natural forces. You've got solar forcing, where sunspots actually alter the sun's physical energy output. You've got massive volcanic eruptions that completely change our atmospheric chemistry. And you even have Milankovitch cycles, which are basically these major shifts in the Earth's orbit, tilt, and wobble. These forces are a huge deal, but here's the catch. They operate on tremendously long, extremely slow timelines.
To understand our current reality, though, we first need to look at a fundamental, natural, and honestly kind of wonderful baseline process, the natural greenhouse effect. If you've ever stepped into a glass greenhouse on a sunny day or walked into a bright classroom in the dead of summer where it's way hotter inside than outside, you've literally experienced this effect firsthand. The glass lets the sunlight in, but physically stops that warm air from getting back out.
Just like the glass in that physical greenhouse traps the heat, our entire atmosphere acts like this giant, invisible blanket, making the Earth habitable and cozy. Without this naturally occurring greenhouse effect, our planet would just be a freezing, hostile rock floating in space. In fact, this natural process keeps global temperatures a massive 30 degrees Celsius warmer than they would be otherwise. 30 degrees. We literally owe our very existence to this atmospheric blanket.
Now, under normal conditions, our global energy budget exists in this beautiful state of equilibrium. Think of it like a perfectly balanced two-way street for radiation. Energy comes in from the sun, and energy leaves the Earth. And as long as that incoming radiation and outgoing radiation stay balanced, the Earth's climate stays perfectly stable and life-supported.
So how exactly does this two-way street operate? Well, first, the atmosphere acts almost like a wide open door for incoming shortwave radiation from the sun. This solar energy travels millions of miles, passes right through our atmosphere gases like they aren't even there, and strikes the surface, warming up the ground and the oceans. But on the way back out, the atmosphere acts like a massive roadblock. It blocks a huge portion of the outgoing long-wave thermal heat from just simply escaping back into the cold vacuum of space. Basically, the atmosphere says yes to one type of radiation coming in, but throws up a giant red cross and severely restricts another type from leaving. That right there is the crux of the natural greenhouse effect. But you might be wondering, what is physically doing the blocking?
To see exactly how this heat gets trapped, we really need to zoom in on the molecular level. And to do that, we're going to borrow some brilliant insights from space scientist Dr. Maggie Ader-Pocock. Breaking this down step by step completely removes the mystery and shows us the pure, undeniable physics of our atmosphere in action.
Okay, step one. As the ground warms up from all that incoming solar energy we just talked about, the Earth emits long-wave heat radiation outwards. It's actively radiating thermal energy, basically trying to send that heat right back out into space.
Step 2. Molecules of greenhouse gases that are just floating around in the atmosphere, like carbon dioxide, for example, they physically absorb this exact type of heat radiation. Unlike oxygen or nitrogen, which completely ignore the heat, greenhouse gas molecules are structured in this really specific way that allows them to literally catch that long-wave radiation, and when they absorb it, they get totally energized. And finally, step 3. These energized vibrating carbon dioxide molecules, they don't just hold on to the heat. They re-radiate it in all directions, kind of like a pinball machine. Because they scatter this thermal energy every which way, a massive portion of it gets bounced right back down into our lower atmosphere and onto the surface. And that is exactly what warms the planet by that crucial 30 degrees Celsius. Think of this natural equilibrium like sleeping under a nice, normal blanket at night. Your body heat is perfectly trapped to keep you warm and stable, right? You aren't too hot, you aren't too cold. The energy your body produces is perfectly balanced by the heat that the blanket naturally lets escape. It's just a perfect, life-sustaining system.
But here is the absolute crucial point we need to make. The massive difference between this life-giving, natural greenhouse effect and the human-enhanced greenhouse effect. Naturally occurring gases warm the Earth by a huge 30 degrees Celsius, but human activity has created an enhanced version that has warmed the planet by roughly 1.5 degrees above pre-industrial levels. Now, 1.5 might sound tiny compared to 30, but in terms of global equilibrium, it's a massive, incredibly rapid shock to the system.
What's happening is that human activity is basically throwing a thick, heavy winter puffer coat over the Earth. We're physically thickening that atmospheric blanket so less heat can escape into space, and way more re-radiates back to the surface. Think about it. If you're sleeping super comfortably under a normal blanket, and someone suddenly throws a heavy winter parka over you, you're going to overheat very, very quickly. Our perfectly balanced two-way street, and now has a massive traffic jam on the way out.
Particularly since 1975, this rapid global warming has been driven by humans artificially thickening that blanket. We're doing it by burning fossil fuels, driving rapid industrial growth, massive large-scale agriculture, and intense deforestation. Unlike those incredibly slow, natural orbital shifts we discussed at the very beginning, these human causes are pumping greenhouse gases into the air at an absolutely unprecedented rate, severely altering the chemistry of our atmosphere in just a few short decades.
And you know what is truly staggering about this? If you look at our atmospheric chemistry, greenhouse gases like CO2 and methane actually make up a tiny, tiny fraction of a percent of our atmosphere. Yet they completely dictate our global temperatures. Earth's atmosphere is mostly nitrogen, about 78%, and oxygen at 21%. Carbon dioxide is only 0.04%, and methane is an almost unbelievably small 0.002%. Yet, because of their unique, superpowered ability to absorb and re-radiate heat, these trace gases hold immense power. Even a tiny, microscopic increase in that 0.04% of CO2 drastically thickens our atmospheric puffer coat.
Seeing just how wildly sensitive this invisible blanket is leaves us with a pretty stark question, and it's one we have to explore next. Which countries are actually thickening it the most, and how will this huge shift in equilibrium shape our shared global future? Because understanding the pure mechanics of the enhanced greenhouse effect, well, that's just step one. The next step is understanding our global responsibility. Because this blanket covers all of us, no matter who puts the extra layers on. So take this knowledge with you, and maybe look at the world just a little bit differently today.